Why? So first of all, question comes that why we are going to have we are just going to study only carbonates compound chapter. Why not? Why not we are studying uh aluminium and its compound and other substance? Why we specially studying the carbonates compound? Do you have any idea? Tell me first. Why we are
Yes,
studying
sir,
this?
because all the other mm, compounds, only carbon and silicon has the valency 2,4.
Yeah, because it is the first element that is among
Can
all the
yes,
element that we are talking about. Okay, so
yes,
carbon is the only one which is going to have four electron in its outer shell, and it is smallest in size. Okay, so this is the one of the major reason that why to carbon we are just going to, because carbon has a special because of its small size. Okay, because of its small size and other tetravalency, covalent bond, and if I'm talking, uh, there are many factors. Okay, so let me show, yeah, so that we can, because it is easier. Do you have these notes that we this is handwritten notes from this group? So let's start carbon itself. So सबसे पहले शासन, if you are just going to deal with it, simple, अगर हमारे पास we are just going to have 3 million compounds in chemistry. Okay, do you understand Hindi? Shasan,
not so
you
much.
not so much. So if I'm talking here, so like you see that carbon, there are 3 million compounds of carbons are present in nature. Why 3 million? Because of some speciality in carbon, there might be some speciality in the carbon. That's why that is going to have large number of compounds. Okay. So if I'm talking that why carbon is so versatile in nature. So if we wrote the electronic configuration of first 20 elements, that is 1, then 2, then 2, 1, then 2.2, 2, 2.3, 2.4, 2.5. So we notice that carbon is the first element that is going to have 4 electrons in its outermost shell. Carbon is the first one. Are you taking the class with laptop or mobile phone?
It's a laptop.
So it is visible to you clearly. So this is the carbon is the first element that is going to have 4 electrons in its outermost shell. After that is silicon. But you notice that in silicon we have 8, 4 electronic configuration. Okay, and in carbon we have 2, 4. There are two shells in carbon. In silicon we have how many shells?
3.
3 shells. And it has because of extra shell, silicon has greater size. Okay. So
Yes,
first of all, if I'm talking about this, it has tetravalency. It can make 4 bonds with 4 similar or different atoms at the same time. This is the first point that because of its tetravalency, it can make bond. Uh, okay. Why it's so versatile means why? First of all, the question comes why carbon is so versatile in nature. Why? The reason behind it is simple that it is versatile because carbon can make 4 bonds at a single time, first of all. Second, is of its small size. Carbon has only 2 shells, while silicon has 4 shells. And because of that 4 shells, one thing happens here that the effective nuclear force, like for example, if you are having carbon, carbon is going to have 2 electrons only, the first shell, and then 4 electrons. So when they are making bond, but in silicon, we are talking about in silicon, silicon has 4 shells. As a result of which the outermost electron shells are far away from the nucleus. They are far away from the nucleus. Okay, they are far away from the nucleus. So the effective nuclear force is weaker here. Effective nuclear force is weaker here. Okay,
we can.
so that's why the bond is not so stable. That's right. And but carbon has force and the effective nuclear force. So big shorter distance from the nucleus due to small size of carbon, the effective nuclear force in carbon to the boundaries or the bounded pair to the boundaries pair of bounded. This is bounded to the bonded pair of electron. Okay, the effective force to the bonded pair of electron is more. Okay, So we can say that the effective nuclear force in carbon to the bounded pair of electron is more in carbon. Okay. And next one is poor shielding effect. What is poor shielding effect? Let me explain you what is poor shielding. So shielding is that you can say one thing that, like for example, this is the carbon atom, okay, and it has proton here, and this is the silicon nucleus. It has 14 electron. Silicon has 14 proton. Carbon has 6 proton. 6 proton. So you can say one thing, sir. It's okay if carbon is having 6 electron in small size, and silicon is having greater size. But you know that the power of the nucleus of silicon is more powerful. The nucleus of silicon is more powerful because it has 14 positive charge. But because silicon atomic number is 40, so it must have 14 electrons in its outer motion. So its power is increased, na? Then this is only 6 proton. It has 14 proton. 6 proton and 14. 6 positive charge is less as comparison to 14. It is greater than double. So if the nucleus is more powerful in silicon, then it can hold that electron. What if the size is greater? If the size is greater, let it be. We can, okay. So
Yes, sir.
simple. So how can we answer this one? There is one thing in the chemistry that we call it shielding effect. When the inner electron rotate, like you see that your fan blade is rotating, okay? So you see that when it is rotating, then the ceiling is not clearly visible to you in that area where the fan blade is there. Ceiling is more clearly visible in that area which is where there is no blade.
Yes, sir.
Okay. So you see a ring or circular structure that is called cloud formed by the blades, and you can easily, so when this electron revolve, they form a electron cloud. Okay. And similarly, 8 electron are there here in the second shell, and 1 2 3 4 5 6 7 8. So when they revolve, they form a electron cloud. As a result of which, the nucleus to the outermost shell electron, the nucleus power, its nucleus is powerful, but its power is not reaching. Like for example, during the summer day, when there is no cloud, you will feel the radiation of sun or hotness of sun means at greater level. Okay, you will feel
Yes,
that.
sir.
But what if uh, what if there is no simple? We can say that uh, like you see that the hotness of sun. But when the clouds come on the cloudy day, when on the cloudy day you see that the sun is rising. Okay, but the hotness you will not feel because the sun is coming clouds are coming in between the sun radiations. So you will not feel that hotness on the cloudy day. Okay. Okay. So during summer you feel more hotness as comparison to during rainy seasons. Why? Because in rainy season there is cloudy, and during clouds will feel less hotness. Okay. So
Yes, sir.
same these electron clouds when they rotate, they revolve. Okay. When they revolve, when they revolve, they form electron cloud over it. And because of this inert electron, the outermost electrons are not, the power of the nucleus is not directly reaching to that. Still, the nucleus is powerful, but its power is not going. That is called shielding effect.
Yes, sir.
Okay. For example, you have something and you start rotating that thing around you, so you will not be visible.
Yes,
Okay. The same thing, the nucleus is powerful, but this nucleus is not clearly visible to the outermost shell electron. So its power is not reaching to the outermost shell electron. Got it?
yes,
Got
sir.
it? So that is called shielding effect. So in carbon, there is poor shielding effect. Means the outermost electrons are there because there are two shells. So the two electrons are not able to shield properly. But in silicon, there is good shielding effect. They can shield it much better. The nucleus power is not good. So whenever there is poor shielding effect, it means that these two electrons are not able to shield properly the nucleus. So its charge will be visible to this one, or will be this electron will experience more force. So the bonded pair of electron will be more stable because here these electrons are not able to shield the positive charge of carbon. Okay, understood? Yes or no?
Yes, sir.
So because of that, we can say that because of poor shielding effect, the carbon electrons, the poor shielding effect, the effect of electrons means because of poor shielding effect of carbon electrons, then silicon electrons. So poor shielding effect means they are not able to hide, so effective nuclear force is more. Okay, so this is a small size. Okay, has silicon has three shells. Then silicon has three shells. The bonded pair of electron has more effective nuclear force than the bonded pair of electrons in silicon. Means because of poor shielding effect, because of poor shielding effect, the bonded pair of electron will experience more nuclear charge in carbon. Because there is poor, they are not able to hide the nucleus. But here, because of good shielding effect, the bonded pair of electron in silicon will not experience much force. So we can say that carbon and silicon both are tetravalent, both have 4 valencies. But due to bigger size in silicon and poor shielding effect, sorry, good shielding effect, the nucleus, the effective nuclear force, because when the electrons are bounded, there will be they will be hold together with this positive charge, na?
Yes, sir.
Nucleus will hold the electrons. If the nucleus is not visible, then how? The bond will be weaker. The bond will break. So when the nucleus is far away from the bonded pair of electrons, it will be weaker. And if it is still strong, but these electrons are shielding the nucleus and the nucleus is not visible to these electrons, like the sun on the cloudy day. The sun is rising, it is powerful, it is having that much heat, but due to cloud, the hotnesses or the radiations are not coming to. So there is no same thing here. You can imagine that in silicon there is like a cloudy day. The nucleus is not visible to them still, the bonded pair of electron. You can understand like this. But in silicon, sorry, in carbon, there is a hot summer day. They are not able to hide. There is very less amount of cloud. They are not able to hide the nucleus. So nucleus is visible and nucleus can hold it. Understood?
Yes, sir.
Yes or no? Okay. The next one is in silicon, result in the more stable bond in carbon than silicon. In carbon, the shielding effect is less. So the effective nuclear force, we called it Z effect. In carbon is more than silicon to the bonded pair of electron. Next one is covalent bond. Next one is covalent bond. So I'm talking about the covalent bond. Okay, I'm talking about the covalent. The covalent bond is found by sharing of electron between the two bonded atoms. And this bond is strong enough, and it is the second strongest bond. Means carbon make bond with sharing of electron. The bond formed by sharing of electron is called covalent bond, and carbon make compound by sharing, which is second strongest bond in the chemistry, which is second strongest bond in the chemistry. In the chemistry. Got it?
Yes,
Yes or
sir.
no? So start writing that why carbon is so versatile in nature. Okay. First is tetravalency, second one is small size, and third one is covalent. Done, Shazil? Noted?
1 minute. Yes, sir, you can say.
What are you doing? You done, Shazil?
Sir, one. Done, sir.
Okay. So, noted this now. Done.
No. Done, sir.
अब समझिएगा ध्यान से. ओके. सो अगर शायद सिंपल सा क्वेश्चन पूछा गया तुमसे कि वाई कार्बन इज सो वर्सेटाइल नेचर, कि कार्बन इतने सारे कंपाउंड क्यों बनाता है, मिलियंस ऑफ कंपाउंड. तो फर्स्ट वन इज दैट इट हैज टेट्रावेलेंसी, that it can make bond with four similar or different kinds of atom at the same time. Second is that carbon is small in size. Because of that, it the bond formed is stronger, or the effective nuclear force is stronger to the bonded pair of electrons. Third one is it make bond with covalent bond, which is the second strongest bond in the chemistry. So there are the three reasons. You understood?
Yes, sir.
Now the question comes that why do carbon cannot make uh, why carbon can't lose four electrons and form ionic bond or gain four electrons? Why carbon cannot lose four electrons? Why carbon cannot lose four electrons? Because as you know that when we are talking about the carbon, why can't it lose four electron and make ionic bond? Like in the NaCl, the sodium continuously loses its electron and form, and chloride ion gain electron. So it loses electron, it gains electron. Okay. So they become, this is the ionic bond. But here there is a covalent bond is covalent bond. Hydrogen, 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 hydrogen. So they are not giving, they are not losing, they are sharing, they are making bond by sharing of it. Why it is so? Why it cannot lose four electron? Because carbon has four electron. As it lose one electron, like for example, it has this two shells and then this shells. Okay, one, two, three, four. Now when it lose electron, the size of the atom will shrink. Why? Why? Because this time greater number of proton are attracting the lesser number of electrons.
Yes, sir.
Okay, here still it has six proton, but total number of electrons are five. Six proton are attracting five electrons. So the positive charge is more, negative charge is less, so it will attract with more power. It is like tug of war. Five students here, five persons here, or okay, and five persons here. So you know that if one of the person from this will left the row, so this will more shift towards that one. If another person loses, then it will more the row will shift more towards okay toward the more number. So same six proton can attract the lesser number of electron easily. Now when it will lose further, the size of the atom further decreases. Now it has two electrons because this time only six proton are attracting only four electrons. So as the outermost shell electron come closer to the nucleus, we require large amount of energy to remove the electron because it is coming to the closer. Like for example, you have a magnet, powerful magnet. You keep an iron nail here. Next time you keep the iron nail here. So you require more power na, to remove this iron nail from as comparison to this position. Same. If the electrons are coming closer to the nucleus, if the atom size is shrinking, okay, so it will require more energy to remove the electron. Understood? I
Yes,
know
sir.
that I know you are taking dinner or something, eating something, कुछ
No,
खा रहे
sir,
हो,
not enough.
so you can finish it up first. तुम try कर रहे हो that space से तुम concentrate नहीं कर पा रहे, so you can finish it. I'm
No,
giving
sir.
you two. It finished.
Yes, sir.
Okay. फिर ऐसे बार बार क्योंकि concentration खराब हो रहा है, तो that's why I'm saying. So what I'm saying here is that why carbon cannot lose four electrons and from iron. As as an atom start losing electron, the size of the atom decreases because greater number of protons are attracting the lesser number of electrons. So the size of the atom decreases, which make it harder to lose four electrons. Means large amount of energy will be required to lose all four electrons. Understood?
Yes,
A
sir.
powerful nucleus is required. A powerful nucleus is required to hold four extra electrons. And why it cannot gain four electron? Why it cannot gain four electron? Why it cannot gain four electron
The
and
nucleus
and
less powerful.
so that for that time it has only six proton. Six proton cannot hold the extra four electron
Yes,
and form C4 minus ion. So for that, a powerful nucleus is required to hold extra four electrons. Means if carbon want to gain four more electrons, like it is having one, two, and then one, two, three, four. This is the original four of its, and four extra in order to complete its octet. So that for that it require more four means large amount of means a nucleus is very important because six proton. It is very difficult for six proton to hold 10 electron. Six of itself and four extra to make it 2,8 electronic configuration. So it neither lose nor it gain. So it make bond with carbon make covalent bond. Okay. Got it? So
yes, sir.
here we have the question. For this, so memorize this question first, and then you have to answer because it is important. It has came so many times in the board examination. So memorize it, and then I will listen it from you. First, copy it down, then I will listen it.
Yes. sir, done, sir.
Done.
Sir, where's the answer for this question? Why
This is
can't
the answer.
carbon four
And
electrons?
the answer why carbon cannot get four electrons.
Yes,
And
sir.
for here it is. A powerful nucleus is required to hold four extra electrons, which carbon don't have. Therefore, it cannot make C4 minus. Done.
Yes, sir.
So you just memorize it fast.
Therefore,
Memorized. Tell me. So the second reason that why I have told you the four reasons. So out of that four reasons, the two reasons you have written there, that tetravalence is small size. The third and fourth reasons are here. Why carbon is so versatile nature. Okay. So since you know that carbon has four electrons in its outermost shell, so it can make bond by sharing of four electrons. I have already told you that it cannot make uh, it cannot completely gain electron, completely lose electron. It will make bond by sharing of electron. We have written the reason why it cannot make, because if it completely loses, keep on losing. So for every electron it loses, the atom size will keep on decreasing, and it will be exponentially more and more energy will be required to remove the next electron. For example, for removing the first electron, we require 100 joule energy. For removing the next electron, it can be 1000 joule energy, 10,000 joule energy. And for the next, it can be 1 crore joule energy. So that will be exponentially, you can say that large and large amount of energy will be required. So all four
yes,
electron we cannot remove. It is very difficult. Okay. Moreover, it has a small size, so it is closer to the nucleus. So how can it lose? And next is catenation. What is catenation? Catenation is a self-linking property of an element. Like for example, like for example, uh, like chlorine can make bond with chlorine atom. This is catenation. Oxygen can make bond with oxygen in the ozone. It is catenation. Okay, like sulfur can make S8 molecule. Sulfur S8. Sulfur can join up to sulfur S8 atoms of sulfur. Okay, like this. So this is a ring, and silicon can also. But so what is catenation? It is a self-linking. Speak with me. It is a self-linking property. Speak with me. It is a self-linking property. बोलो मेरे
It,
साथ में जो बोल रहा हूँ. It is a
no,
self-linking property
it is a self-linking property
by which
by which
an element,
an element
or an atom, okay,
or an
can
atom
make bond
can make bond
to its own kind atom,
to
to
its
its
own
own
content.
kind atom. It is the property by which, speak
It is
again,
property by
okay,
which
an element
an element
or an atom
or an atom
can combine or make bond
can combine or make bond
with its own kind atom, with its own kind,
its
अपने ही
own
जैसे,
kind.
okay, like chlorine. So this oxygen is showing the catenation property maximum to 3 atoms. Sulfur is showing the catenation property to 8 atoms. Sulfur 8, 3, 4. Phosphorus can show this property up to 4 atoms. But due to carbon small size, tetravalency, and covalent bond, it shows the catenation property to the maximum extent. It shows the catenation property to the maximum, self-linking property to the maximum extent. It can make bond in with because of which it carbon can make bond in chains, in its long chains, in branch, like this, in rings, in the form of rings. Okay. So different carbon atoms can join in different forms. So this is the way that how why carbon is able to make large number of compounds. The simple reason is because in carbon, because of carbon small size, tetravalency, and uh, covalent bond, because it make bond with covalent, which is the second strongest bond. The three reasons. Carbon show the catenation property to the maximum extent. Understood?
Yes,
So carbon show this property to the maximum extent. So what is catenation? It is a self-linking property of an element by which an element can make bond of with its own kind or similar atom. Okay. But in case of carbon, due to small size, covalent bond, and tetravalency, carbon show catenation property to the maximum extent. Means thousands of carbon atom can combine together. Sulfur is showing up to 8, oxygen is showing up to 3, silicon is showing up to 8 or 9. But carbon, long carbon at chain is there. Thousands of carbon atom can join. So as a result, it make bond in branches, straight chain and rings. Okay, so it is very important. Note it down and then memorize it fast. What is catenation? Done.
No, sir.
Done.
Yes, sir.
Okay. Tell me what is catenation property? What is catenation property?
It is a self-linking property of an element or an atom that it can make bond with a same kind of atom or a similar kind of
And why do carbon show catenation property to the maximum extent? Why do
atom.
carbon show catenation property to the maximum extent?
In carbon, because of tetravalency, covalent bond, and small size, it shows catenation at the maximum extent.
Now, both silicon and carbon, a question comes in examination. Both silicon and carbons are tetravalent. They both have four valency. Okay. Uh, but silicon can make bond up to 7 to 8 atoms. Silicon atom combined together. 7 to 8 silicon atom combined together. While carbon can make chain up to hundred of thousands of carbon atom bonded together. Why it is so? So same reason, because of a small size of carbon. Carbon has two shells and silicon has three shells. Okay. The bonded pair of electron has more effective nuclear force than the bonded pair of electrons in silicon. Got it? As a result, the bond formed in the silicon is weaker or in carbon is stronger than silicon. Got it? Simple
Yes,
reason
sir.
is that if I ask you that both carbon and silicon both are tetravalent. So we can simply say that carbon, there are the two shells. In silicon, there are the three shells. So here the outermost shell electron in carbon, 1, 2, 3, 4. Then it is far away from the nucleus. It is closer to the nucleus. So bond is stronger in nucleus. So we can simply say that in silicon, there are the three shells. And in carbon, there are the two shells. The size of carbon atom is smaller than the size of silicon. So the effective nuclear force on the bounded pair of electron in carbon is more than silicon because silicon has greater distance. Okay.
Yes, sir.
Will you so note down this answer? The question is this one. Question is this one. Right, start writing from here. This is the question.
Yes.
And this is the answer.
Yes, sir.
Up to here. When you're done, please let me know.
So, done, sir.
So now you understood?
Yes, sir.
Now, next we'll learn the अभी हमने जो सीखा है वो ये सीखा है इस क्लास में, that why do carbon is so versatile in nature, what is catenation